In these examples, we're going to write linear equations representing a couple of different scenarios. The key with each of these is that we'll have a fixed amount and a variable amount. In each, the variable amount will vary at a constant rate, something that's a key feature of a linear equation. In the first one, we're told that an appliance repair person is hired to fix a dishwasher. The company charges $89 for the service call and $119 for each hour of service. We're going to write a linear equation representing the total charge. To start, we'll want to define each of our variables. The total charge is something that varies and is unknown, as is the number of hours of service. So, we'll let T be the total charge measured in dollars. And this total charge depends on the number of hours of service. So we're going to let T be the total charge in dollars for H hours of service. And the variable letters that I choose, I have a lot of options there. I could choose X and Y if I wanted. Here I've chosen letters that indicate which variable I'm referring to. So I've chosen T for total charge and H for hours. Okay, now we have a fixed amount that we're given, and that fixed amount is the $89. So that's going to be charged regardless of whatever else happens with the number of hours of service. So let's identify that fixed amount of $89. And then our variable amount is this $119 for each hour of service. So that's a rate. So our variable amount is that $119 per hour. So to figure out the amount we're charged, we'll take $119 times each hour, and that'll give us the total variable amount. To compute the total charge, let's write T, and now we can write our equation. So our fixed amount is $89, so we're going to take that 89, and then we're going to add 119 times H, and that 119 times H will compute for us the total amount for each hour. So if we have 1 hour, we'll take 119 times 1, 2 hours, we take 119 times 2, and then that fixed amount, that 89, is just going to stay as the constant. In this second example, we're again going to have a fixed amount and a variable amount, but we're going to have to do a little bit more manipulation in this one. So let's get started. We're told, a roofing company is hired to install vents that improve the ventilation of a home. They charge a flat fee of $200, and that flat fee includes the installation of the first 3 vents. After that, each vent that is installed costs an additional $60. We're going to write an equation representing the total cost. So again, before we get started, let's define those variables. So we're going to have a total cost, and then we're going to have some number of unknown vents. So let's define, and let's use C this time. We'll let C be the total cost, and that total cost, so it'll be measured in dollars, so we'll say in dollars, and it's going to depend on how many vents are installed. So we'll say let C be the total cost to have V vents installed, and I've chosen V as my variable there to indicate that it's for vents, and capital C for total cost. Now we again have a fixed amount, and that's that $200. What we want to note here is that that fixed amount of $200 includes 3 vents. Our variable amount is $60 per vent, but that's only after we've had 3 vents installed. So variable amount is $60 per vent, and that's for additional vents over those first 3. So let's get started. We know that C is going to be 200 plus something. And now we can't just take 60 times V. And let's think about why. If we took 60 times V, then if we had 4 vents installed, we'd be charged 60 for each of those 4 vents, but the first 3 should be included. So if we think numerically for a moment, if we have 4 vents installed, we're going to need to only pay for one of those. So we would take 4 minus 3 and get 1 to figure out that we need to be charged 60 for that additional 1 vent. If we had 5 installed, we would need to then subtract 3 to figure out that we have 2 additional vents over those initial 3. Same pattern, if we had 6, we'd subtract 3. We'd get 3. If we were having 7, we'd subtract 3, and then we'd have 4 additional vents. So the vents over 3 are what we're concerned with, and we can see from this pattern that we can represent that with V minus 3. And that's what we're going to be charged. That's the number of vents over 3 that we have. So completing our equation representing the total cost, we have that 200 plus, and then now we're going to take 60 times V minus 3. Again, V minus 3 representing the number of vents over 3 that we have.